Hey everyone, hope you are doing well and welcome back to another video here on the channel. In this week's video, we're going to be taking a look at a battery pack and determining if the one that I just recently purchased is a good battery pack for speed run vehicles or does it suck. Now the battery that we're looking at here today is this one. It is branded by Zeee. It comes in this black and blue hard case. We don't care necessarily about the looks of the case and how it looks, although it does look good. We care about the performance of this pack. This is an 8,000 milliamp hour pack that has a C rating of 100. This is quite substantial in the RC industry, especially if the C rating is quite accurate. Now 100 C with 8,000 milliamp hour available on tap is quite significant. This is going to equal out about an 800 amp continuous discharge rating that this pack says it's got. Now what we want to do is we want to test for performance. We don't have the means of testing an 800 amp load on this battery pack, and quite frankly I know what would happen if we place an 800 amp load on these packs. It's not going to be a big surprise. These batteries will not be able to handle it, and I do want to keep these batteries for a little bit longer than a day or so. So what we're going to do is we're going to take a look at the initial charge that we perform with this pack. We're going to take a look at what kind of internal resistance we get with that in a controlled environment. We're going to take that internal resistance, we're going to drop it into a calculator so that that calculator can tell us what is the actual C rating that we expect from this pack as it relates to specifically only the internal resistance of the pack. Then what we're going to do later in the video is we're going to look at some data, performance data that comes right from a few runs that I'm going to make, and we're going to look at what kind of performance that we're getting out of the pack while it is under load, while the car is moving, and giving us the performance that we ultimately require to make the fastest and best passes that we can make. Closer to the end of this video, we're going to use that data and we're going to compare it against an older pack. This is about a pack that is 5 years old and is a 4,000 milliamp hour capacity with a C rating of 45C. This is another pack that is used in the Limitless V1 for 8S passes, as you've seen on the channel here before. We're going to compare those results to ultimately determine if this battery is good or does it suck. So let's get started and take a look at some of the data that we've collected. First thing that we need to do here is charge up the pack here on the left. We're going to use a charge rate of 12 amps. 12 amps comes from the standard test procedure of charging at 1.5 C multiplied by our 8 amp hour battery pack. That gives us the 12 amps. I'm going to initiate the charge here by pressing the play button on the charger, and once this is going, I want to go in here and take a look at the voltages. This is the first time I'm looking at the voltages. I'm just checking to make sure that they're all consistent, and then I can move on here to channel 2. I'm going to do the exact same thing here on channel 2. I'm going to start the charge at 12 amps. It's good to know that this particular charger has the internal resistance values show up on the screen at around the 1 minute mark, and this is what you want to have on your charger as well, the values somewhere in around the 1 minute mark. As you begin to charge for longer periods of time, let's say upwards of the 20-minute mark, you're going to have some heat put into those cells, and that ultimately changes the internal resistance measurements and values. Same thing if you took your radio controlled pack and you dropped it onto the charger after you just made a run. You're going to have completely different values. Here we can see that our first values coming in at the top are 4.2, 4.6, 4.2, and 3.6. These values are definitely quite high. It's not too often I see some very large packs with very high C ratings at values that are that large. Now skipping forward, we're going to take a look here at the values. We're going to see that they're coming in at approximately the same as our other pack. They might be a little bit lower at 4.0, 4.4, 3.6, 3.5 there as well. What I want to show in this last clip here, ignore the internal resistance value, because as the charge rate begins to ramp down, the internal resistance value is going to be inaccurate. What I want to show is that flat line. Look how long it takes for the charge to terminate. That shows you that the pack has high internal resistance for what it's worth. Here is the RCexplained Patreon community calc sheet. You can have access to this too by downloading a copy. You'll have access to all the formulas within this spreadsheet, as well as all the different calculators that can be found on the bottom as represented by the individual tabs. We often use the car gearing speed KV calculator here on this channel. So what we want to do is we want to enter in, I'm going to actually probably more than likely change the way that we do this. I think it's better to represent this based off of more recent testing that I've done within the last couple months, the average internal resistance of the LiPo battery pack. We have 8 cells. I'm going to put in the average internal resistance that we did see here, and that was 4.04 milliohms as represented by 8 of those cells of 8,000 milliamp hour. We're going to throw in the 8,000 milliamp hour as a result here. It calculates the battery pack's real C rating. Now the C rating for this Zeee pack comes out at like 13.9 C based off of the test that we have here today, which is purely an internal resistance test. This represents a maximum continuous current that's recommended of 111 amps. Now 111 amps, I do believe that these cells are going to get hot if it's running at a continuous 111 amps. That's going to put pressure on this battery and more than likely bring it past that 140-degree Fahrenheit mark, ultimately leading to a failed battery according to the way that we test. We don't ever want to see 140 Fahrenheit. Now, just as a comparison, I'll show here, this is a different cell count, but another battery pack that I have made by Turnigy, and it is a 5,000 milliamp hour, and the highest cell internal resistance, if I change that to the average internal resistance, it's about 0.8 to 0.9. Let's put in 0.9 milliohms, and here you can see that the pack is rated for 60 C and it comes in at 37.3 C as the real C rating for that specific battery pack. Now let's switch gears and take a look at some of the loaded data that we got from this battery pack that we used here today. Switching over to this spreadsheet, here is a calculation that I've done for multiple different passes. I used the Castle Creation software to help me get this, and I've took snippets of every pass that I've made, and this is the results that we got. So essentially what I've done is I've put in here the cell count that we're using, 8 cells, the unloaded voltage, the loaded voltage, and this is what we're getting all from the spreadsheet, as well as a calculated difference. So I just take one, subtract the other, then we put in the current value, and this is going to calculate the individual average cell resistance here. Now, this is typically going to be about 60% plus or minus. It does vary depending on what we're doing and how hot the cells are getting of the original test that we've done, where it came out at an average of 4.0. So 4.0 averages out, it's about 60% what we're seeing here for the average internal resistance. What is really cool here is that the average internal resistance of each one of these calculations here, taking at multiple different passes along a couple different days, shows up as different values. So this is all taken along day 1, and this here is taken on a different day with very similar results, which is surprising. They all come out to about 25 thousandths of an ohm, which is not what you would expect from an 8,000 milliamp hour 100 C pack. Now what I want to do is I want to compare this to another pack. This is going to be a very similar pack that we showed there in the previous screen where we looked at the internal resistance from a 5,000. This is the graphene, same Turnigy company, but this is 5-year-old packs, and they're 45 C rated, and this is a 4,000 milliamp hour pack. So this is half the capacity and half of the C rating. This is the performance that we're getting here on one day. So we have, using values from 3 different runs here on the top side, a different day where we ran 2 runs, probably more, but I've taken 2 measurements here from it. We show very consistent results here again with 2.2 milliohms, 2.3, 2.2, 2.1, and 2.3. Keep in mind, this has got half the capacity, half the C rating, and it is better performing than our 8,100 C packs that are literally brand new. These guys are 5 years old and they perform better than my brand new packs. When these things were brand new, they were rock solid for a 45C pack. They would often deliver some great performance. And if I were to go and switch my screens here to this guy and put in what I saw when these packs were new, it was a 4,000 milliamp hour pack, and I was seeing approximately 1.3 milliohms, showing me that the 45C pack was actually closer to like a 35C in reality, which is really good. A 35C pack for 4,000 milliamp hour, that's a great pack to have. We start out here with 30.5 volts or 29.7, and then we arrive at a loaded voltage of 23. This is a massive amount of voltage drop. Here you can see we're losing 6.7, 7.5 volts. Here we're losing 9 volts, but of course we are doing this with a higher current draw. Either way, in all of these passes here, all 4 of these passes, we end up with the resistance per cell on average of 2.5, 2.4 milliohms. This is exceptionally high for a 100C 8,000 milliamp hour pack. If we're racing for top speed, we typically want to see packs that are delivering an average cell resistance here of around less than 1.5 and ideally under 1 milliohm for those high performance top tier packs. I was expecting from these Zeee batteries that if I have a C rating of 100C, I definitely knew that 100 was out to lunch, but I would expect that it should be, equal or equivalent to the 45C graphene packs that I have. However, the 8,000 milliamp hour capacity being literally double the 4,000 milliamp hour capacity should drop the resistance by a significant amount. I was ultimately looking for this Zeee battery pack to come in at less than 1 milliohm per cell while it was being charged up under room temperature, and then once the pack heats up and is being run within the Limitless, I was expecting it to climb even a little bit lower on the ladder and get around the 0.5 to 0.8 milliohm mark per cell. Ultimately, these batteries were not able to perform to the expectations that everyone should have for an 8,000 milliamp hour battery pack and a 100C rating. Therefore, these packs indeed, unfortunately, they do suck. Well guys, hope you enjoyed this video. As always, like the video if you do, and don't forget to hit that sub button so that I can see you guys in the next video. Thanks a lot for watching. See you in the next one.